So Pandas also has some plotting capabilities so that you're able to interpret your analysis or your conclusions or how you've modeled your data into quick visualizations on the go. Now, it doesn't do this on its own. It does this in tandem with a library that we'll be looking at next week called Matplotlib. But the functionality is also inbuilt within Pandas. So you can call .plot function on a data frame and it will be able to plot the given values. And this is not only limited to data frames, it also works with series as long as it's a Pandas data structure. So you can plot an array of, you can utilize .plot to plot an array or different types of, the number of numerical data types in our data frame are 3. We have 1 float and we have 2 integer columns. So when we run .describe on our data frame, you see it only identifies the 3 numerical data types, and it's able to do the statistical analysis or statistical breakdown of those particular columns. So when you call .plot, it only identifies the numerical columns and plots them. It leaves alone all the others because it's very hard for you to plot an object or a string in the form of a line graph. Yet again, when you call .plot directly, it will always revert back to using a line plot, or what is called a scatter plot in this case. Now, scatter plots can be in different formats when you specify exactly what structure you want it to appear in, either the dots or just a single line. And then what it plots on the y-axis is the values within the given numerical columns, while what makes up the x-axis is the index. So this is where the index now starts really mattering, because it's what Pandas will revert back into confirming from whenever it's plotting the values. But you can emphasize more of what you wanted to plot against. So we could say senior citizen to tenure by declaring x equals to senior citizen and our y value to be tenure. And you can see it's able to figure out what is the right type of plot and plot it out. Okay, you can also plot based on a specific column. So when you call a single column, as we've seen from a data frame, that's a series at this point. Type. That's a series. So the same functionality also works whenever we're calling our plot with series. It will take the x-axis to be the index and then the values within that particular column to be on the y-axis. Now, for those who are familiar with data science, data analysis, or statistics, you understand the concept of outliers and understanding the breakdown of your data, just as we used .describe. Now, in a visual term, we can translate this information here into such a plot, whereas the lowest bar down here demonstrates the minimum value. The bar starting with the whole square, not the square, the rectangular setup demonstrates the first quartile, the middle bar within the rectangular structure, the median or the second quartile, the ending of the rectangular section being the third quartile, and then the top bar completely being the maximum value within each particular column. So In the case of outliers, you tend to see a lot of dots either above this given bar or below this given bar, meaning that there are values that are not attributed within a particular range. They're awkward. So if you're working with, let's say, data for students in a university, you expect university students to be between the ages of, at the very least, 16, if he's a genius, he or she is a genius, all the way to around, well, it's very hard to know what the maximum age of somebody in a university could be. So specifying probably for a degree, maybe maximum 60, 70, or something like that, if I'm being very liberal. Yeah. But if you're working with such a data and then you see one person having the age of 10, that's questionable, and that could be considered to be an outlier because it's significantly outside the range of what you're expecting the values to be. So that's what I mean by an outlier if you're not familiar with them.